calculus from 0 to hero. Hey everybody, so in this video we are going to discuss high school calculus, right? So we're going to start with basic differentiation, then we apply it to finding the equation of the normal, the equation of the tangent. We will move on to integration. We will look at indefinite integrals, right? I will explain what these terminologies means, and then I will also discuss definite integrals. All right, so let us get started and see what we have, right? So this is how differentiation works. So if I give you, for example, x to the power n, right, then I tell you to differentiate. So differentiation, we normally say the derivative of this expression with respect to x. So that is d of this expression and dx, right? So what you basically do, you drop the power n, right? So after dropping the power, you reduce the power by 1, n minus 1, just like that, okay? Then you also have to note that the derivative of a constant, say c, is equal to 0, okay? The derivative of a constant is equal to 0. All right, guys, so let us look at an example. So for example, e.g., you have, so these are real exam problems, right? So number 1, so let us take y to be equal to x squared minus 3x minus 4, okay? So I tell you to find the derivative of that expression, okay? So in 3, 2, 1, can you guys check what that means? All right, so let us go ahead and see what happens, right? So if we say differentiate y with respect to x, right, it means you want to find dy dx, okay? So because this expression is an expression with sums of different terms, right? So it means you differentiate each term, right? So number 1, look at this, right? I have the derivative with respect to x of x squared, right? So I just take that one. Then from our rule, we said you drop the power, that is 2, and then you reduce the power by 1. So this is 2, right? The power is 2. When I say 2 minus 1, it's 1, right? So I just write x because I know x is already to the power 1, right? Okay, then the next one is d with respect to x of negative 3x, okay? So what is this? So x has the power 1, right? So this will just be negative 3 multiplied by 1, okay? Then if I write on the side here, x has power 1, then I reduce 1. This becomes x to the power 0, which is just what? Which is just 1, right? You see that? So x to the power 0, it is just here, it's just 1. So this becomes negative 3, okay? Then the last one is dx of negative 4. So because this negative 4 is a constant, right? So we said here that the derivative of a constant is 0. So this becomes 0. Okay, guys, so therefore, right here, I'll write therefore dy dx, right? The derivative of y with respect to x is equal to, I just take the sum of these values that I found. So the derivative of x squared, we found that it was 2x. Then minus, I have a minus here, minus 3, right? So minus 3, okay? Then the derivative of negative 4 is 0. So we don't include a 0 here. So meaning that the final answer, if you solve this, is just 2x minus 1, minus 3, okay? let us try a different problem. So the second problem says, so number 2, right? So given that y is equal to x squared minus x plus 4. So we want to find dy dx. So what is dy dx? Can you guys do that quickly? Yeah. What is dy dx? Or what is the derivative of y with respect to x? Okay, so let us do this one quickly because now we already know how to do it. So I'll write the derivative of y with respect to x is equal to, okay, so remember here the 2, we drop the 2, then x, we subtract 1 from 2, that is just the power 1. I'll just write it anyway so that I show exactly what I'm saying. Then minus, so x has to the power 1, this is just 1 multiplied by, I mean x, you know, is 1 to the minus 1, right, which is just 1. So 1 multiplied by 1 again, then plus 0, okay? Then we can just simplify this as 2x minus 1, okay? That is just 2x minus 1, guys. All right, so if that is clear, let us now apply these things, right? So application. So by saying application, I want to apply them to solving problems like finding the equation of the normal, the tangent, and so forth. So remember if, right? So I'll write if y is given by f of x, right? If y is given by f of x, then what does it mean? Then the gradient of the normal, or the slope of the normal, I mean the slope of the tangent, so let me write m sub t, right, is just the same as, you know, dy dx, or here is just same as f prime of x, right? So this is the other notation of derivative, f prime, okay? So this mt, right, mt is the slope of the gradient of the tangent, okay? So that is number 1. Then 2, this implies that, you know, slope or gradient of the normal, I'll write m with a subscript m, with subscript n, right? So this is just the same as minus, right, minus 1 over mt, right? Mt is the slope of the tangent. In other words, we can write, you know, mt, mn is equal to -1, okay? So in some books, they just write m1, m2. The product of these two gradients is -1. That is just the bottom line of everything that I'm saying right now. Okay? Let me know if you guys are following. All right, so if that is clear, let us give another formula. So number 3, this is the third formula. So the equation of, you know, a line, right? Any line can be formed by y minus y1, right? Let me just see my screen. Okay, so we said y minus y1 is equal to the slope m, then we are going to subtract x minus x1. So this is at the point x1 comma y1 with slope m. Okay, so we have the slope m, we have the point, right? Then we can form an equation using that. Okay, so these are the formulas that we're going to work with. So first of all, know how to differentiate, right? You're just dropping the power and reduce the power by 1. Then the derivative dy dx is just the same as f prime of x. Okay, so the derivative is the slope of the tangent. Okay, then the relationship between the tangent and the normal is that they are perpendicular, right? They meet at 90 degrees. So meaning that if you have the slope of the tangent, which is mt, then the slope of the normal is m sub t, their product is -1. Okay, so given one, you can find the other. All right, so let us see good examples. So examples. Okay, so let's see. If I give you y is equal to x to the power 2 minus 3x, the same one that we started with, minus 4, then at the point say 2 minus -6. So I ask you to find the equation of the normal. So let's say find equation of the normal to the curve, right? Okay, so the first thing is we need to differentiate, right? So what is the derivative? So let's see, the derivative of y with respect to x is, we found what? We found 2x minus 3, right? We found 2x minus 3. We just dropped the 2, subtract the 2, do 2 minus 1, right? 1 from 2. Then here x is to the power 1, so 1 minus 1 is 0. X to the power 0 is 1, so that is why we just have 3. Then the derivative of a constant is 0, so we don't have anything. Okay, so what this means here is that, you know, the let's see, m sub t, this is the slope of the tangent, will just be, you know, because the value of x is what? X is 2, right? In the coordinate here, this coordinate is x comma y. Okay, so 2, we are going to substitute the 2 here, put 2 minus 3. This is just what? This is just 4 minus 3, which is equal to 1. So meaning that the slope of the tangent to this equation or to this curve is 1. So therefore, the slope of the normal, right? The slope of the normal, m sub t, we said this is just -1, right, over the slope of the tangent. The slope of the tangent is 1. So this is just -1. Okay guys, so we are almost done, right? So remember, we are dealing with the point 2, -6, right? Then we have the slope m of the normal, which is -1, right? So what would be the equation, right? So remember, we said, let me just rewrite the formula here. We said y minus y1 is equal to m. In this case, we have m sub n is x minus x1. Okay, so what does this mean? So therefore, let me just push a little bit up here. Okay, so this means, I need the question within me. Okay, this means y minus, where there is y1, I put -6 because -6 is in the y coordinate, right? So I have -6 is equal to m is -1, then x is what? X minus x1, right? x1 is 2, like that. Okay, then I can just expand, right? So this is just the same as, you know, y minus, that is plus, right? Because of negative multiplied by a negative number, or minus negative is plus 6. This is just negative what? negative x, then plus, right? Negative 1 minus multiplied by negative 1 multiplied by negative 1 multiplied by negative 2. That is a 2, right? Okay, guys. So what does this imply? We can go ahead and subtract 6 from both sides. So I'll write here. Therefore, the equation of the normal will be what? So if I subtract 6 from both sides here, right, I will just have negative x, then 2 minus 6 is what? Is negative 4. Okay? So that's it, right? Let me know if you guys are following. Okay? All right, so if you guys are following, let us go ahead and look. Check another example. So let's see. I'm going to use the same equations that we used when finding the derivatives. Right, so we want, what are we asking for here? Okay, so let's see. So we want to, let's say, find equation of the normal. Okay, find the equation of the normal to which curve? To the curve y is x2 x squared minus x, right, and plus 4. Okay, remember we need a point, right, at a point negative 1 comma 6. Okay, negative 1 comma 6. So let's see. So if this is, let's see if this is a curve. It's not going to be exact, but let's say this is negative 1. Maybe 6 is right here, right? So let's see if x is 0. Oh, we're going to have, right, so let's see, yeah, maybe something like that, right? So if we have that, and then maybe the slope, maybe there's a line that passes like that. Okay, it's not like, an exact kind of graph, but you have something like that. So this is the line of the tangent to this curve, say at this point. Okay, so the equation of the normal will just be like that, right? Because it has to be perpendicular to that line. Okay, this is not an accurate graph, but it is just, I'm just giving you an idea of what that means. So let us find the derivative again. So we said dy dx is what? Let us go ahead and drop the 2, right? So this is just 2x minus 1. Okay, so we found this at the beginning of this video. Let's see now, what does this imply? This implies m of the normal, right? The slope or the gradient of the normal will just be 2. Where there is x, I put negative 1, then minus 1, right? Okay, so this is what? This is just minus 2, minus 1, which is negative 3. So the slope of the tangent, sorry, this is slope of the tangent. The slope of the tangent is negative 3. So therefore, slope of the normal, what we want is minus 1 over the slope of the tangent, right? So this will be minus 1 over negative 3. Okay, but this is negative and negative, so it becomes a positive, right? So 1 over 3 is the slope of the normal for this problem. So again, we say the equation is y minus y1 is equal to m. In this case is m sub t sub n, then x minus x1, right? X minus x1. Then what do we have? What do we have, guys? Let us go ahead and substitute. So this is y minus y1 is 6, right? Is equal to m is 1 over 3. Then x minus x1 is negative 1. Okay, so that is why I just put that. Okay, so we can go ahead and, you know, simplify, right? So if I do that, we have y minus 6 is equal to 1 over 3x, right? Plus, right? Because negative multiplied by negative number, it's plus. Then 1 over 3. 1 over 3. Okay? So we are almost done because we can write this now. We can add 6 both sides. So this becomes y is 1 over 3x. Okay? So this is plus 1 over 3 plus 6, right? Plus 6. So let me make 6 as with a denominator 3. So I can add 3 over 3. Okay? I just want to add this, right? So this is just the same as 1 over 3x plus the denominators are the same. We add the power. So 6 multiplied by 3 is 18 plus 1 is 19. So this is 19 over 3. Okay? So the equation is y is equal to 1 over 3x plus 19 over 3. Okay? Are you guys still there? All right. So now let us move ahead to definite or indefinite integrals. Okay? Let us move ahead and look at indefinite integrals. So the integral of the powers, right? Integral of a number to some power. So for example, if I have the integral, right? So this is the symbol for the integral of x to the power n with respect to x. This is just the same as what? So remember, for the differentiation, we were dropping the power, right? But in this case, we increase the power by 1, n plus 1, right? Then the new power, we bring it in the denominator, right? Then if there are no limits on the integrals, we add a c plus c. Okay, in this case our n is not equal to negative 1. Okay, so this is the general formula for differentiation with of polynomials, right? Okay, so let us look at simple examples. Let's say, what is the integral of x to the power 4 with respect to x? Okay, so here you just increase x by 1. So x 4 plus 1, everything divided by the new exponent. The new exponent is 4 plus 1. Then we add a c, right? So a c here, we call it the constant of integration. Okay? We call it the constant of integration. But look at this. We can simplify this further. Right? So this is bad way of writing. Let me write it in the below here. So this is x to the power 5 divided by 5 plus c, right? Okay, that's it, right? That's it. So let us look at another example. All right, so let us look at another example. So another example is, let's say, so find the integral of 6x squared minus x plus 3 with respect to x. Okay, let's do that. Let us find the integral of 6x squared minus x plus 3. Okay, so how does that go, guys? How does that go? All right, so let us do it fast, right? So remember, we have to when you have the integral of a sum of expression, right? Or I'll just say the integral of a sum, it is just the same as the sum of integrals. The integral of a sum is just the same as the sum of integrals. So this integral, remember, it's an operator, right? So it can be distributed throughout. So let us distribute this integral. So we have integral of 6x to the power 2 with respect to x, right? Then minus the integral of x with respect to x, then plus the integral of 3 with respect to x. Okay, just like that. Then we can use what we know, right? We can integrate each term by term, right? Term by term. So let us start with the first one. So the first one is the integral of 6x squared. So remember 6 is a constant, so we can just put it out, right? But here we are going to have, let's say, 6 multiplied by x. So we said we increase x by the power of x by 1, so it becomes 2 plus 1, which is 3. Then the new exponent is 3, which we divide here, right? So I didn't write 2 plus 1 here, just went directly. Then minus, so x is x to the power 1, right? Let me write it somewhere here. X to the power 1. So if I integrate, this one becomes what? x1 plus 1 divided by 1 plus 1. Okay? So it becomes x to the power 2 divided by 2. Okay? Then I had, right? So remember, for a constant, the integral of a constant, if I have the integral on the other side here, integral of let me say integral of 3, right? Remember, 3 can be written as 3 multiplied by x to the power 0, right? Because x to the power 0 is just what? Is just 1. Okay, so this is the same as 3, then x 0 plus 1 divided by 0 plus 1, with just x. I'm just showing it in case you are seeing this for the first time. So this becomes 3x. Okay, but remember, because this is an indefinite integral, we add a c. Okay, so let us go ahead and simplify this. So I can divide, right? This is just 6 divided by 3, which is 2. So this is 2x to the power 3, then minus x to the power 2 over 2, then plus 3x plus c. Okay, so this is our indefinite integral. Okay. All right, guys. So let us now move ahead and consider definite integrals. Okay. Let us consider definite integrals. So I write here definite integration. Okay. So let me start with an idea. Okay. So if I give you the integral, right? This is the integral from a to b of f of x with respect to x. This is just the same as you find the antiderivative of f of x, which I can write maybe by a capital letter, say f, right? If the antiderivative of f of x is f, right? So we're going to evaluate f at b, then subtract f at a. Okay. So in a nutshell, given the integral of f of x from a to b, the key is to find the antiderivative f of x. Okay. Then when you find f of x, you just subtract the capital F at b minus the capital F at a. Then you are done with indefinite integrals. Okay. We're done with definite integrals, guys. So let's see. Let us look at examples. So the more practical exam kind of problem is they would normally say evaluate. So what are we evaluating? The integral from -1 to 1, right? From -1 to 1, then say 1 minus 4x plus 3x squared with respect to x. Okay. So if this is the case, then let us find, so the first task, right, we said it is to find capital F of x, the antiderivative of this expression that is inside. Okay. So since now we are expert, we know that the antiderivative of 1 is what? Is just x, right? We just have x. Okay. Then minus. Now here, remember we have a 4. Let me write it down. I have a 4. Then we have x. So we raise it to the power 2 divided by 2, right? I have to write it down because there's some cancellation. Then plus, we have a 3x. We raise it to the power 3, right? Because this is x squared. So plus 1 to the power 3 divided by 3. Okay. So here we're not adding a c because we have limits, right? So this simplifies to, x, then minus 4 divided by 2, it will be 2x squared, then 3 and 3 cancel. This is just plus x to the power 3. So this is the antiderivative, right? Okay. So if this is the case, then remember our formula says the integral, right, -1 to 1 of 1 minus 4x plus 3x squared with respect to x is just the same as this capital F that I found at 1 minus the same capital F at -1. Okay? At -1. So let us go ahead and do that. So what is f at 1? f at 1 will be, so the f is, I'm referring to this expression here. Okay, so where there is x, I just put 1. So this becomes 1 minus 2 multiplied by 1, squared is just 1, then plus 1 to the power 3, it is just 1, right? So this is just 1 minus 2 plus 1, right? So 1 minus 2 is negative 1, plus 1 is 0. So that thing is a 0, okay? Then the next thing is to compute f at negative 1. So where there is x, I put negative 1 minus 2, negative 1 squared plus negative 1, then to the power 3. Okay? Then let us go ahead and simplify this. Right, so this is, let me write it. No, I can write it here. This is just 1 minus, because this is negative 1 squared, so it will be 1, right? So this will just be 2, right? But this is negative 1 to the power 3, which is negative 1 multiplied by negative 1 is positive, multiplied by negative 1 will be negative. So this is minus 1, okay? So negative 1, I have negative 1 at the beginning first, sorry. So negative 1 minus 2 will be negative 3, then minus 1 will be negative 4, okay? Then the last step now is to find f of 1 minus f of negative 1. What is this? This is just, 0 minus negative 4, okay? 0 minus negative 4, which is just 4. So meaning that for our integration here from negative 1 to 1 of this expression, the answer is just what? Just 4, right? Just 4. Like that. Okay? So that is what we have so far. All right, so I see finding area under the curve, right? So for you to find the area under the curve, we use the same, the same method, right? However, you would need some equations, right? Let me see if I can give an example. So let's see. So okay, I can use the same example actually. So for example, if you look at this this equation, this expression here, right? If you look at this expression, say, let me see, because I want to see my paper properly. Okay, yeah. Let's say this is the x or y plane, and then maybe this was maybe your curve, something like that. Okay, then maybe you have, this is your negative 1, and this is your 1. Okay, so this graph here, right? This graph here is your graph y, which is equal to f of x. Okay, so if this is y is equal to f of x, right, then the area under this curve here, right, the area under this curve is just the integral of your f of x with respect to x from negative 1 to 1. Okay, so in our situation, if f of x was given by 1 minus 4x plus 3x squared, then the area under this curve is just the integral of this f of x, right, from negative 1 to 1. Okay, so again, it depends on the question that you have been given, but the area under the curve is the same process we do for definite integrals. I hope that that helps. I hope that helps. Okay. All right. Okay, so let us go ahead and proceed. Let's go ahead and proceed. Okay. Okay, so the next problem, says evaluate so this is the integral from -1 to 1. No, let's type to 4. -1 to 4. Then let's say 2 plus 2x plus 6x squared with respect to x. Okay, like that, right? So we have 2 plus 2x plus 6x squared with respect to x. Okay, so again, fast forward, right? So we need the capital F, right? So remember, this is just the same as f at 4 minus f at -1. But what we don't know is f, right? So our antiderivative is f. Okay, so what is this f? So f of x is equal to, so the integral of 2, you remember this is just 2x, okay? Because 2 multiplied by x to the power 0, 0 plus 1 is just 1, so that is why we have 2. Then the next thing is this, right? So remember, x to the power 1 will be added to 1, then divided by 2, right? So this just becomes x squared, okay? Then plus, this just becomes what? This just becomes 2x to the power 3, okay? Why? Because this is 6x squared. The integral will be what? 6 divided by 3, okay? Then x to the power 3, right? That is 2 plus 1. So 3 into 6 is 2 times. So that is why we have 2 here, okay? So again, for those who are wondering like how we find the area under the curve, so if this is your curve, for example, let's say this is your curve, right? So this could be your -1, sorry, and this could be your 4, okay? So this area under the curve, for example, from -1 to 4, where f of x, the root to f of x is described by this formula, right? This expression will just be this integral from -1 to 4 of this expression, okay? Now we have f of x, right? So meaning that the integral is just, you know, f at 4 minus f at -1. Okay, so let us go ahead and find f of 4. Okay, so f of 4 is just 2 into x plus, into x into 4, sorry. I meant to write 4 here. Where's my eraser? Okay, so this is just 4, then plus 4 squared plus, I'm just substituting, right, 2, then 4 to the power 3, okay? And then, you know, when you do your math properly here, you should get what? 2 multiplied by 4 is our 8, then plus 4 squared is 16, then 4 to the power 3 multiply 4 to the power 3, that is 4 multiplied by 4 multiplied by 4, which multiplied by 2, which will just be 128. Okay, so you can use a calculator here. This becomes like 152. Okay, then the next thing is to compute f at -1. Okay, so what is f at -1? F at -1 is just 2 multiplied by, remember when there is x here, I just put -1, so 2 minus 1, then plus negative 1 squared, then plus 2 negative 1 to the power 3. Okay, just like that, right? Are you guys following so far? Okay, so what is 2 multiplied by negative 1? Can you guys send your solution in the chat? 2 multiplied by negative 1, it's negative 2, right? Okay, so what about negative 1 squared? Negative 1 squared is what? Is just 2, right? So this is 2. Okay, then what about 2 multiplied by negative 1 to the power 3? So remember, this is negative 1 multiplied by negative 1 multiplied by negative 1. So the 2 negatives cancels, negative 1 remains, right? So this becomes, I don't know why I wrote 2 here, but 1, right? Then this remains negative 2. Okay? Okay, why negative 2? Because you have negative 1 to the power 3, which is negative 1 multiplied by 2 is negative 2. Right, so let us do this, right? So negative 2 and minus 2 will be negative 4, then plus 1 will be minus 3. Okay, good. So we have our f at 4, which is 152, then f at 1 is negative 3. So therefore our final answer should be what? F at 4 minus f at 1 at negative 1, which is just 152 minus, it will be minus, right? So which will be plus, right? Plus 3. Okay, so this is 155. Okay, 155, right? Okay, all right guys, so that is how we find the area under the curve, or just indefinite integrals. Okay, so let us do more